In this video, I'm going to give a brief review of how to find the vertex of a parabola and what does that indicate about whether a quadratic function has a max or a min. So let's look at an example. Does this function f of x equals negative 2x squared minus 7x plus 3 have a max or min, and where does it occur? Okay, so the first thing I'm going to do is, with this equation, I can write this as y equals instead of f of x equals to think about it in terms of the x coordinate and the y coordinate. So y equals negative 2x squared minus 7x plus 3. So I know this is a quadratic. This is a quadratic. So that means the graph is a parabola. Graph is a parabola. And the key to knowing whether it has a max or min is whether that parabola is upward facing, like this, or if it's downward facing, like that. And what indicates that to us is the leading coefficient. So whatever is in front of the x squared, the a term. So here that is a negative number. And because it's negative, that means we are going to have a downward facing parabola. A downward facing parabola. Okay, so let me just draw a picture. So let's say I have a downward facing parabola like this. If I have a downward facing parabola, the vertex, so the vertex is this point here in the middle of it, we have a max there. We have a max at the vertex. Okay, so the fact that our parabola is downward facing is what indicated that we had a max there. If our parabola had been upward facing, then we would have had a min at the vertex. Okay, so now the second part of the question is, well, okay, let me box this. We have a max at the vertex. Now we know that. Second part of the question is, where does it occur? So to answer that, we need to find the vertex, find where it is. So we can find the vertex by, so I'm going to mention two ways. So the first is by completing the square. By completing the square. Or, and the other way that I'm going to talk about, and this is the one that I'll actually end up using, is by using the vertex formula. So out of these two methods, if this was a pre-calculus class, I would likely show you both of these in detail. But since we just have a brief amount of time to do this review, I'm going to pick and choose one, and I'm going to choose the quicker one, and that's vertex formula. I'll briefly just mention that completing the square is the more illustrative method. Like when we complete the square, it's more obvious from the process and the answer that I end up with why the vertex is what it is. Although the process is longer. But I like it more because it's more illustrative. I think it's more conceptual. The vertex formula, on the other hand, is definitely quicker, but not illustrative. Just by looking at the formula, it's not immediately obvious like where it comes from and why it gives us the vertex. Okay, but nonetheless, we will use 2 due to time. Okay, so the vertex formula is x equals negative b over 2a. This is the x coordinate of the vertex. Okay, so I'm going to highlight this. X equals negative b over 2a. So now if we plug in what b is and what a is, we'll end up with negative 7. So negative 7 on the numerator. On the denominator, we get 2 times negative 2. So overall, we end up with negative 7/4. And that's our x coordinate of the vertex. But we still need to know the y coordinate. So to get the y coordinate, we can take this x value and plug it in for the x in the equation. So we get negative 2 times negative 7/4 squared, and then minus 7 times negative 7/4 plus 3. And I'm just going to go ahead and skip the simplification here, but if we were to work out what this is, we end up with 73 over 8. And now we can go ahead and write down the vertex. So our vertex, this is where the max occurs. The x-coordinate is -7/4 and, comma, 73 over 8. And in our problem, the vertex is where the max occurs, because we had a max at the vertex because it was a downward-facing parabola. All right, so in terms of our goals at this point, we've reviewed how to find where the max or min of a quadratic function occurs by finding the vertex.